What I would like to cover with you today are some of the key things we have learned about what works and what doesn't about implementing generative AI systems in practice. So we'll talk about what we've learned about long context. We'll talk about agentic systems, small language models, domain-specific models, and AI governance, topics that you'll hear about in much more detail later in this summit. One big thing that came about this year and became obvious is the fact that what you don't want to do when you build an LLM system is take everything you know about the problem, dump it into the LLM, and then ask it the question. It seems obvious from many respects that even if you have a long context LLM, just telling it everything that you think might be relevant and asking it to filter it out and decide what it needs to happen, it does not work because of problems like context rot, which is basically telling it too much so that it does not know what to ignore, and attention delusion, which is similar to what happens to you. As you know, as a human, it's much easier to summarize a 10-page document than to summarize a 1,000-page document about the same topic. And what we see are more and more papers and more technical reports that recommend being much more selective and much shorter with the contents that you supply in LLM. More than that, there is growing evidence in terms of scientific research, reproducible research, that says that the context length itself, by itself, causes accuracy drops for current frontier LLMs. And for example, you can see here 2 papers and the kind of drops they reported, but the first one is interesting because what they've shown is that even if you have perfect retrieval, so even if you manually guarantee that the answer is within the context you gave the LLM, just the fact that this context is larger is going to cause accuracy drops. And even if you completely mask the irrelevant content, okay, so it does not try to be misleading, you're going to see accuracy drops across a variety of tasks, right? So question answering, coding, reasoning, mathematics. When you try to look at tools or evaluation, this is even more severe. Basically, when you hold the chat for longer, when you add the number of tools and the number of agents, you're going to see that accuracy significantly drops really from usable to non-usable very often. So what you should do instead, and there are many techniques to do this, is manage LLMs basically the same way you manage humans. You only provide them the context they need for the current tasks, and you try to keep it very selective. So for example, in summarization, LLMs still struggle with summarizing very long documents of hundreds of pages. So what you want to do is take the hundreds of pages, first split them into sections, first create an outline, and then ask the same LLM or another LLM to summarize each section separately, right? So that no one needs to be overwhelmed, really, in the same way that the human would be overwhelmed from trying to summarize the whole thing at once. And this seems to be the case when dealing with long documents and also when dealing with drug systems, where many of them show that actually providing the LLM with fewer RAG results is going to improve accuracy, or summarize RAG results instead of the raw one would also be better than just dumping everything into the LLM. So that's one big trend this year. The second one is agents, and you'll hear a lot about it in this summit. And one interesting with agent is that very often they apply this exact strategy. Instead of going to one LLM and asking you to do something, you basically ask it to call a bunch of agents that it needs to coordinate, and each one of them only deals with a small slice of the context and small slice of the task. So that's one reason why agents seem to work, but it's not the only one. And the second big thing we've learned this year, and we see very consistently across studies and real-world implementations, is that multi-agent systems often outperform one LLM. So that, for example, especially when you're dealing with complex reasoning tasks, instead of taking the document, giving to a frontier LLM and asking for the answer, do this. Ask multiple agents or multiple LLMs. Ideally, make them diverse in some way in how they were trained, who they were trained by, what the prompts are, and then have them debate the answer. Okay, so where they disagree, they need to basically chat among each other, debate, and vote at the end on what the correct answer is. And this seems to be significantly increasing accuracy on more the complex reasoning tasks, so mathematics, coding, arithmetic, legal reasoning. It does not have as much impact on kind of straightforward tasks. The second example here is centered on the US medical licensing exam, where yes, LLMs do really well. But if you have 4 or 5 of them that each basically takes the tests on its own and then they debate, and when they disagree, what you see is that this debate process fixes wrong answers 5 times more often than it breaks correct ones. We not only see it with papers from earlier this year, we also see this with papers really from the past 2 weeks, past 4 weeks, and even things that are measuring against things like GPT-5, Gemini 2.5 Pro, Claude Sonnet 4, kind of really the newest current frontier LLMs. If the tasks are complex enough in terms of the reasoning and the chain of thought that's required there, you're going to see that orchestrating multiple LLMs is going to give you better answers. The other interesting thing about agents is that because each agent by itself is smaller, you can also get responses significantly faster and significantly cheaper than calling something like GPT-5, right, or the latest Sonnet model. Which leads me to the third and the next trend that seems to be in play, which is small language models, which it's not that they've making a comeback, it's really that they've never went away. So of course we started the machine learning, deep learning revolution with small task specific models. Then there was a real question 2 years ago and a year ago about, look, will we even need them, or should we just plan to have one gigantic LLM that will do everything? And it seems to be, if it were never obvious before, it seems to be obvious again now that that is not the case. And more than that, specifically, if you're looking at agentic AI, here's a fairly famous paper from NVIDIA from earlier this year that argues why agentic AI specifically fits, is a good fit for small language models, because what you're trying to do is exactly what we just discussed. Not have one expert do everything, but split the task into many experts, each ideally with diverse expertise, diverse experiences, and then you have them debate and decide what the overall answer is. And if you do that, it's very important those models are small. You want them to be sufficiently powerful, so sufficiently accurate on the one tasks you need them for. And you need them to be, the other thing, because they're smaller, it's very important they're cheaper and faster. Because usually what you cannot afford is take 5 or 10 big LLMs and call all of them, because then the cost of running each task becomes 10x, which is not acceptable. What will work is splitting the task to 10 much smaller, much simpler agents, where often, as you'll see, you can get responses actually much cheaper and faster than you would with one LLM. So here are some recent papers from the last 3 to 6 months that show those types of things. There's paper that shows that if you fine-tune small language models against current frontier LLMs, you're going to generate significant accuracy gains on those specific tasks. This is very consistent from what we've seen in Johnson Labs in the healthcare space. Fine-tuning a small task-specific model will often give you a higher accuracy, of course, only on that specific task versus general-purpose LLMs. The second paper here is from our work at Johnson Labs, looking at one thing that people often not think about until they try to do things in production, which is the fact that one benefit of small model is that they can often be deterministic. And if you're in the healthcare space, you don't want to be able to tell a doctor or a patient, well, if you don't like what the model, the diagnosis that they gave, you just run it again, it will give you something else, right? That also does not fly as well, if you're trying to get a recommendation for a legal course, a financial plan, and so on. You just want to get the correct answer, right? And not something that changes every time you ask the question. And of course, the third issue is cost. So these 3 papers really map very nicely to the NVIDIA paper, in the sense that Here are the three things that make specific small language models specifically a great fit for agentic AI. Sufficiently powerful, right? You need them to be at least as good or better on the specific task they're in charge of compared to a large LLM. Inherently more suitable, which in many kind of real business environment really means they're deterministic, right? They actually follow the law and follow the business logic you need, and more economical role. So you'll often see 1 to 2 orders of magnitude cost and latency improvement by using small models. One example from Johnson Labs, and we see this very often because we do get the question sometimes, why aren't you doing anything on LLMs? And the answer remains because it's not always, not only the best result, it's not always even a good result. And one very common use case for this is medical data de-identification. So one of the things that Johnson Labs provides is the ability to de-identify data from multiple modalities with regulatory grade accuracy. So we can de-identify medical text, medical images, PDF files, right, including ones that are scanned. And here's a peer-reviewed papers from earlier this year that does comparisons with, in this case, GPT-4o, GPT-4.5, Cloud Sonnet 3.7, which was the frontier models when we wrote the paper. And really, you can see two things. First of all, a small task-specific model just outperforms those models in terms of accuracy, and significantly so. I mean, it makes the difference between a 0.98 and a 0.90 F1 score is really that you're making 5 times fewer errors, right? And really, usually 4 to 5 times fewer PHI, so sensitive entities you forget or miss when they're identifying, so it's material. And the second thing is around cost. These models do not even require a GPU. They only require a GPU if you're de-identifying images, where you need really one commodity GPU, meaning that if you do this over a large number of documents, it's going to be an order of magnitude cheaper to run, infrastructure plus software. But beyond kind of our work in healthcare, the fourth trend that I want to talk about is domain-specific models, where there's been a lot of debate, and to an extent, it's still an open question, whether we'll have really one model that does all industries. Really, what is the gain you can get by tuning model to a specific industry? And last year, we had quite a few papers around this. So, for example, here, Qwen 2.5 Math that was specifically tuned for mathematics and was by far the best performing model at the time. The model specifically built for finance, model specifically built for law, as you can see here, for example, that really were fine-tuned for legal tasks, right? Finding similar cases, predicting legal judgments. But this is also happening this year. Here you can see, for example, a paper from just 2 months ago, looking at the radiology and analyzing radiology reports, also still showing very significant gains, in this case as with GPT-4o, in kind of on those specific tasks. And really, what you can see is the more specialized the domain is, the more gain and benefits you have if you make the effort to fine-tune that model. And one of the things we've seen at Johnson Labs is that this is most visible in the healthcare space, because healthcare is really its own language, its own semantic, its own domain, and something that's kind of understanding healthcare is very different than understanding English or understanding kind of generally how the world works. Here you can see 10 of the recent benchmarks that we have focused on. What we wanted was to go beyond the traditional information extraction, de-identification, look for tasks that require really a general understanding of more diverse tasks, and also real-world tasks. So all these tasks come from the MedHelm dataset. MedHelm is a holistic evaluation of language model project for healthcare, built and developed by Stanford University. And as you can see here, there are tasks around answering consumer patient questions, being able to generate a treatment plan, given say, a surgical report, being able to summarize a dialogue between a doctor and a patient, right into summary report, right, including history, assessment, and plan. and also things like identifying bias or identifying hallucinations in giving answers from scientific literature. So those are kind of the kinds of benchmarks that we looked at. And what you have is really a fresh from 2 weeks ago benchmark that compares Johnson Labs' most recent healthcare-specific medical LLMs to the current frontier models, so to OpenAI's GPT-5, Google's Gemini 2.5 Pro, and Anthropic's Sonnet 4.5, which I think by itself is only 2 or 3 weeks old, showing, once again, not only that healthcare-specific LLMs can materially outperform those general-purpose frontier models, but also that it's possible to do it with far smaller models. So Johnson Labs models, basically, they're not available as an API endpoint, because for privacy and compliance reasons, the way that they work is that you install them within your environment and they run there, so that you never have to send patient data or confidential data to any third-party API. But then, of course, the concern is, okay, how much hardware do they need to run? And these models, specifically Johnson Labs model, have outperformed the current frontier models, run on 1 GPU. So as you can imagine, those are far smaller models. And this is what we often see in healthcare, that not only can you consistently and materially outperform general purpose frontier models, you can do it with models that are at least an order of magnitude smaller and more efficient, right, from a speed and cost perspective. The fifth and last trend that I want to call out and that we'll cover here in the summit is AI governance. In the summit, we have a whole day for the first time this year focused on governance. And this is because there are now, as you can see, more than 250 laws, regulations, and industry standards that may apply to you before you send the project to production. So even if you only care about accuracy and you don't care yet about testing it properly or monitoring it properly, you probably do care about doing things legally, because you are not allowed to deploy illegal software to production, and there are laws concerning everything from transparency, bias, privacy, copyright, and everything in between. And there are domain-specific legislation. There's legislation specifically for healthcare, specifically for finance, specifically for insurance, specifically for HR processes. And there's also more general purpose ones around the responsibility, right, of AI developers and AI deployers. One thing to call out, because it's free, it's the Pacific AI Policy Suite that actually gives you a PDF that's a 70-page PDF of the policy suite that covers, for policies that cover all of these legislations. But beyond that, as we are engineers and data scientists, it's also interesting to know how we actually implement them, right? So what are the tools, what open source libraries, what testing libraries, what monitoring tools are there? And we'll cover all of that in the third day of this summit. And with that, I would like to thank you for your time. You know where to find me, right here in questions or on LinkedIn. And if you have learned this year things that are different than what I spoke about or things that conflict with it, please do let me know so that I can learn as well. Thank you.